Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from automatic generation control. The name of the topic is turbine speed governor system. So the question might be asked like this: draw the schematic diagram of speed changer and a speed governor and mark the linkages and linkage point moving. So this is what is the diagram. Here you will see there are four important points. First one is the speed governor, second one is the hydraulic amplifier, then third one is nothing but this is the linkage mechanism A, B, C, D, E, and fourth one is nothing but a speed changer. In a modern and a large interconnected system, manual regulation is not feasible, it is not possible, and hence automatic generation and the voltage regulation equipment is installed on each generator. So this figure gives a schematic diagram of a load frequency and the excitation voltage regulators of the turbo generator. The controllers are set for a particular operating condition and they take care of any small changes in the load demand without exceeding the frequency and the voltage above the prescribed limit. With the passage of the time, as change in the load demand becomes large, the controllers must be reset either manually or automatically. So let's have a look for the first thing is nothing but a fly ball speed governor. So if you see, these are the two balls which are shown here. I can write the name of these is nothing but fly ball. So what is to be observed here? This is the heart of the system. This fly ball is the heart of the system which will sense any change in the speed. Now, if the speed is more, I will write it here. If n is more, then what happens to the balls? I will write it here. The balls will move outward. The balls will move in an outward direction. So let's say I will draw this diagram. So these are the balls which will move in an outward direction. So what is the meaning of this fly ball moves in the outward direction? We will understood that the speed is more. Now, as these fly balls, whatever these fly balls here we have connected, as it moves in the outward direction, what happens to this point B? This point B will move in the downward direction. And on the other hand, if the speed is lesser the speed, what happens to the fly ball? So I will write it here. Fly ball will move in the inward direction. Fly ball will move in what? It will move in an inward direction. So what will be the diagram here? So this will be the diagram here. It will move in the inward direction. And as it moves in the inward direction, what will be your point B? That point B will move in the upward direction. So we can say this fly ball speed governor, it is nothing but heart of the system which senses the change in the speed, or on the other hand we can say that speed change in the frequency, because ns is proportional to your change in the frequency. So as the speed increases, the fly ball will move in the outward direction, and the point B from the linkage mechanism, it will move in a downward direction, and the reverse will happen when the speed will decrease. Now the next important point is nothing but hydraulic amplifier. So this is the structure. From this you can say this will be the structure of hydraulic amplifier. Now let's have a discussion about this. It includes two main points. First one is nothing but a pilot valve. So this will be your pilot valve, and second one is nothing but a main piston. So this will be your main piston. Pilot valve needs low power and main piston requires high power. But obviously, if you see the total volume here, the volume of the pilot valve is less as compared to that of your main piston. So the power which will be required for the movement of the pilot valve, it is less, and the power which is required for the movement of the main piston, it will be more. Here, the low power level pilot valve movement is converted into high power level piston valve movement. Now, why it is required? It is necessary to open and close the steam valve against high pressure steam. So let's see what happens here. Now high pressure oil will enter from this gap. As high pressure oil will enter from this gap, it will be accumulated here. Because of that, what happens? This piston, we can say, it will move in the downward direction. Now as it moves in the downward direction means what? Your point D will also move in the downward direction. So I will draw the diagram here for understanding, so that it will be easy for you to understand the things very properly and clearly. So I can draw this. This is nothing but your, let's say this is your point number D. So now here to the point number D, what we did here, we have connected one, I'll draw it here. We have connected here one piston. So let me draw this. This is what is the diagram that we have. Here if you see, this will be your piston portion. Now here your high pressure oil will enter from this. I can draw this directly like this. Here it is connected to this point, piston, and this is the rod which is connected here. And similarly if you see, it will be connected to this. And what is this? This will be, I can draw it here. It is nothing but what? This will be your main piston. So this is your main piston. This will be your high pressure oil. And this is nothing but what? This will be your pilot valve. Pilot valve. Now this will be connected, if you see the diagram, it is connected to the point E. Let's say it is connected to point E. And here there will be a steam inlet. This is steam inlet. Now what happens when the high pressure oil, let me take other color so that it will be easy for me to show you how the things has been going on. So as the high pressure oil will enter into this, it will be accumulated here. Now what happens? So I will draw it here. So this is your piston. It will move like this. It will move like this. And here if you observe, now let me rub the things here so that it will be easy for us. So what you observe here, what happens here, as this piston will move here in the backward direction, as the piston will move here in a I can say not a backward, it will be in a downward direction. What happens? The oil will be accumulated here. This high pressure oil will come here. This piston will, let's say, move by some amount. Now this high pressure oil will enter from this area. It will be accumulated to this point. So what you observe? This high pressure oil will try to move this main piston part in the upward direction. So what you observe here, D will move, when D will move in the downward direction, as soon as your high pressure oil enters into this, your E will move in the upward direction. E will move in what? It will move in the upward direction. And on the other hand, what the other thing is, if let's say if the high pressure, the exactly opposite will also be there. Here when D moves in the downward direction, E will be in an upward direction. And when the D moves in the upward direction, then E will move in what? It will move in a downward direction. So when the first case has been seen, that is when the high pressure oil will come here, this piston will move in the downward direction, high pressure oil will enter from this to this region. Then the main piston, this high pressure oil will create a pressure to the main piston and it will move in the upward direction. So that's why this steam inlet, it will be reduced. This steam inlet will be reduced. So this is the diagram. Whenever the D moves in the downward direction, let's say up to the point, let's say D dash. So this is what is, we can say that this is nothing but your hydraulic amplifier. So what it includes, already we discussed. It includes pilot valve and the main piston arrangement. So lower the power level pilot valve movement is converted into high power level piston valve movement. And why it is required? It is required in order to open or close the steam valve against high pressure steam. Now the third one is nothing but these are the linkage mechanism. A, B, C is the one linkage mechanism, and C, D, E is the other linkage mechanism. These are the rigid linkage. ABC link is pivoted at B. Pivoted at B means what? It will be either like this, move, it will move like this, or it will move like this. This is your A, this will be B, this is C. This is A, this will be B, this will be C. Pivoted means it is fixed at point B. And similarly, CDE is the other linking mechanism which is pivoted centrally at point B. So what is the role of this linking mechanism? This linkage mechanism acts as a feedback system and it provides the feedback from the steam var movement. It provides the feedback from steam var movement. Thus, it provides a movement to the control valve in proportion to that of change in the speed. Now, next is nothing but a speed changer. Here if you see, first one is the lower level, second one is nothing but a raise level which is shown. It provides a steady state power output setting for the turbine. Now, what happens to the downward movement of this A and what happens upward movement of this point A? Its downward movement opens the upper pilot valve so that more steam is admitted to the turbine under a steady state condition. And the reverse will be happen whenever the speed changer moves in the upward direction. So let me write here few important points how we can remember this, how we can remember the moment of the linkage mechanism. So I will write it here: A, second one is B, third one is C, then D and E. Now let's say if the speed is more, so what will be the position of speed changer? Now the more means what? Raise. So the raise has been shown at this point. So therefore, when I will draw here this arrow in the downward direction, the moment is nothing but what? When the speed is raised. When the speed is more, then what happens? Already we have studied in this speed governor mechanism. More the speed, the fly ball will move in the outward direction. The fly ball will move in what? Outward direction, and point B will move in the downward direction. So more the speed, what happens? A will be in the downward direction, that is at raise position. B also will move in the downward direction. Now the exactly opposite will take place to the C. Now as B is in a downward direction, C will be in the upward direction, D will be in the downward direction, and E will be in a upward direction. What is the meaning of that? As the speed is more, the speed changer will move in a raise condition, that is in downward condition. It is sensed by these two fly balls, and fly balls will move in a outward direction. Point B will move in the downward direction. Point C will move in upward direction. Now what happens to this point D? As the high pressure oil will enter from this to this region, towards this region, if you see, this D will move in the downward direction. So this D moves in the downward direction, and here the point E will move in the upward direction. So whatever will be the steam inlet, that will be closed. So I can write it here, it will be closed. So this is the case when the steam will be, or we can say when the speed will be more. On the other hand, I can write for decrease in the speed. This is A, B, C, D and E. So as the speed changer will sense that there is a decrease in the value of speed, so it will be at lower position. So lower means what? I can represent this like this. It will be a lower. So as A will be lower, what happens to the B? Already we discussed. This speed governor or the fly balls will sense the changes in the speed. So lesser the speed, the fly balls will move in the inward direction, and as it moves in the inward direction, what happens to the point B? It will move also in upward direction. So point B will move in upward direction, point C will be in downward direction, point D will be in upward direction, point E will be in downward direction. So what you observe? Lesser the speed, your B will move in the upward direction, C will be in downward direction. Now here D will be in upward direction. What is the meaning of D in upward direction? Now this high pressure oil will be enter from this, because this piston, or we can say pilot valve, it will be at this position. Okay, and this high pressure oil will enter from this area and it will be accumulated to this area. So because of that high pressure oil, what happens? Your main piston will move in the downward direction, and as it moves in the downward direction, meaning is nothing but what? More gap will be created and more amount of the steam will be inserted towards the blade of a turbine. So this is what is, we can say that, turbine speed governor system. Now the main important point is, what is a governor control? What is the role of this? Now we know that the load in the power system changes instant to instant. At any particular time, load may be different. After 1 hour, load may be different. If the load on the generator increases, the speed will decrease and vice versa. That we know because already we have studied. More the load, then lesser will be the speed and also lesser will be the frequency. Now change in the speed will result into corresponding change in the frequency, and the change in the frequency is not acceptable. Change in frequency is denoted by delta F. It should not be more, it should not be less. Hence, it is necessary to use the governor to sense the speed and adjust the input to the generator to compensate the load. In earlier days, the flyball governor was used, but nowadays some electronic governors are used here for sensing the speed changes. The electronic governors are fast and accurate. The governor control ensures a match between input and the output to keep the frequency of the output voltage constant. So this is what is the topic of a governor control. So if the question is asked, draw the schematic diagram of speed changer and speed governor and mark the linkage and the linkage point moment, then we have to draw this diagram, and whatever here I have shown, A, B, C, D, E linkage mechanism, what happens when the speed will be more, N is more, speed is more, then this is the case, and when N is lower, then this is the case. You have to write all the parameters, all the things, what is speed governor, what is speed changer, what is linkage mechanism, and how the hydraulic amplifier will work. So this is what is the turbine speed governor system. Thank you for watching this video.